In this part of the video, I'm going to show you how we can map a geometry, an object, onto a surface, which might be, in this case, it might be a spherical dome. The first step is to define a box around this module, this folded plate module, a box that kind of bound the entire volume in it, and then define a kind of like three-dimensional grid all over that spherical dome, and then map this box, this kind of like a bounded box, onto that three-dimensional grid over the sphere. The component that we're going to use is box morph. Box morph. In box morph, we define what geometry we want to work on. Let me just graph this one. So this is the geometry that we want to bound. And then it asks for a reference box. That reference box is a box that kind of bound the entire object that you want to map. There is one component, it says bounding a box, which gives you a very straightforward box. You can connect any sort of object that you want to it and then get that box all around it. This is a very simple component, but in case you're going to map multiple surfaces, like our case that we have like multiple folded plates, might not properly work in some cases. So what I'm going to do instead of using a bounding box is just like simply creating a box by defining the rectangle and the height. We already have that rectangle, and I'm going to give the height, and the height is the height of that center point of our moved rectangle that we talked about it in the previous sections of this video. So this is the reference box. Oh, this one. We are going to connect it to the reference box. And the third item is the target box. The target box is actually an array of boxes that are mapped onto the surface. In order to do that, first of all, I'm going to use a component that says surface box. Here, the surface box. The surface box asks for the surface that we want to define a twisted box over it, and it asks for the domain. The domain is actually the number of divisions along the two directions on that surface. That two directions might be X and Y, or in this case that we have like a spherical surface, might be a radial direction and a meridional direction. In order to divide two-dimensional directions, we use divide domain 2, divide domain square. So I connect that surface, which is actually the base domain, and then I define the number of divisions along the first and the second direction. So here I will create two sliders and divide the domain, and then connect the domain here. Here is the box. Here is the sphere. Earlier in the previous video, when I was creating that surface, I defined the angle for revolving to pi, but now I change it to 2 pi because I want to make sure that the divisions will happen in 360 degrees, not 180 degrees. So here is the target box, and now what I'm going to do is connect it to the box morph. We're not yet done. As you see, that modular folded plate part is not properly morphed onto the surface. The reason is that here we have a series of surfaces, and in order to make sure that all of them are morphed onto that box, we need to graft that data tree. Now you can see that our folded module is nicely morphed onto the surface. Let me just turn this off. Okay, here we go. So here is our folded plate dome, and you can play around with the parameters, change the divisions along the meridional direction or along the radial direction, or play around with the other parameters that we defined in the previous parts. Earlier here, I told you there might be a little bit of difference on how you create a surface, a spherical surface, and I suggested you to create that dome surface by revolving the surface, but not by a spherical surface. Let's try to do that again and then see what is the difference. So again, what I'm going to do here, I have this surface. I want to morph box morph that geometry, the geometry folder plate module. The reference box is that box that I defined there. And now let's see how we can create the target box. Again, for the target box, what I'm going to do is creating a surface box. Surface box. Oh, surface. Nope, no, I don't write out surface box. Here it is. And this is the surface. And now I should divide the domain square. And, similarly, I'm going to connect it to two sliders. So here we are, and this is a domain. What happens here is that target box, as you see here, is defined over the entire sphere, although you split the sphere throughout the process and you itemize that surface and you connect the surface to like the target surface. So this, I would say, this is a kind of glitch in the way that Grasshopper can process our program. It kind of needs like additional supplemental script to say that, well, you shouldn't get back to the original definition of the sphere and like divide that into the number of divisions that we're saying. So it will be a little bit tricky to make sure that you're dividing the dome properly. So that's why I suggest you not to do that. So if you do this, you see that the entire sphere will be splitted into boxes, and then the folded plate module will be mapped onto the entire sphere. So this is the end of this part. Now in the next video, I will explain how to create a folded plate vault.